All right, here we go. It's only 4 questions, right? Let's do this. Identify the vertex and the axis of symmetry for the function. So first, it's asking just for the vertex. So we're going to do one thing at a time, okay? Looks like you guys are still getting your stuff ready, so I'll give you a second. This is lesson 7.2, homework. Homework help. Yep, 7.2. It is asking for both the vertex and the axis of symmetry, but we're going to answer them one at a time. First, let's define each one of these terms so we understand what we're actually looking for. Somebody describe what a vertex of a quadratic function is. There are a couple of different ways to describe it. You can raise your hand or you can shout it out. Yeah, Callie?
X squared.
That's the vertex?
I don't know what it is. X is, oh wait, 15.
No. We're defining just what a vertex is of any quadratic function or any parabola. How would you describe the vertex?
It's a coordinate pair.
It has a coordinate pair, yes.
F of X.
Do you guys not know what a vertex is?
Oh, it's like the thingy of the graph.
You could describe the vertex as h comma k. Okay, so here's a couple of different ways to describe a vertex. Ricky gave kind of like the coordinate pair notation, hk, h and k being part of vertex form. I actually wasn't thinking about that specific one, but totally fine that we're including it. I would like to describe what a vertex is in general.
It's the points.
It's what?
The
The
points.
points? So
For a line. No.
the points for a line?
Yeah, like the.
So a vertex is multiple points?
No, the center.
The what?
I don't know.
I think you do know, that's why I'm asking you lots of questions. I'm not going, no, you have no idea what you're talking about. Sometimes I do that. I'm like, no, stop. But you are onto something. I just want you to hone in on that definition because it's definitely not points.
Oh, 8 points.
Okay, it's a point on a parabola. How would you describe what that point?
It's like on 2 straight lines.
On 2 straight lines. I'm trying to, that reminds me of the book Madeline. The girls in 2 straight lines. Huh?
The raised feet.
The what?
The raised feet. Like the raise, like the.
Oh, the rays. Okay,
Yeah.
yes. Okay, they're not quite rays, but let's call them curves. Okay, where the 2 curves meet. I actually like that definition. So this could be one way to describe it. Where the 2 curves of the parabola meet. Love that definition.
Or the opposite of where
Opposite. Opposite of what?
the base.
Okay. What about, there's a phrase that I've been using to describe the vertex, and I use it when I'm describing the behavior of the parabola reading it from left to right. I'm saying, when I say like, okay, the parabola is decreasing over this interval, then it has a blank, and then it starts increasing. It's 2 words, starts with T, P. What phrase have I been using that describes the vertex?
Tail of the parabola.
Okay, so when a parabola goes from decreasing to suddenly increasing, or goes from increasing to suddenly decreasing,
Time parabola. Stable function. Transaction.
Turning point?
Yes, very good.
I thought
Turning point.
I thought turning is like forward.
Turning
Oh my
point
God.
over down.
Oh, I forgot about the ing. I forgot about the ing. My bad.
The turning point. The vertex is the point where the parabola turns or changes direction. So we can say that it's the point where the two curves of the parabola meet. You can also call it the turning point of the parabola. Another way to describe this, and I won't try to make you guys guess it because I don't think that you'll quite get there unless I really spell it out for you, literally. But you can also describe the vertex is the point on the parabola that also falls on the what?
Y-axis.
Not necessarily the y-axis.
Oh, the way yeah,
Very good. Sorry, I kind of chucked that at you. So the vertex, which we might call HK when we're thinking about vertex form, is the point where the two curves of the parabola meet. It's also the turning point of the parabola where it changes direction. It's also the point. Anybody taking notes on this? I'm writing this.
Yeah.
Okay, good. The point on the axis of symmetry. I just kind of made that one really long M to be two M's. The axis of symmetry. So we really described kind of four ways, including the HK, four ways to describe the vertex of a parabola. All of them are correct. Now that we totally understand what a vertex is, what it looks like, where it's located, how it's represented, we can talk about how to identify the vertex of a function. Now, before we try to answer this specific question, let's talk about what the x squared part is. What does that remind you of when it's just x squared?
1 squared.
What does it remind you of? What, like, this function is,
the parent function.
yeah, the parent function. So the parent function, which is f of x equals x squared, and it looks exactly like this, literally has these points exactly. So that's our parent function. This is the little baby. How is this little baby different than the parent function? Before we worry about the vertex, let's analyze how this is different.
15.
The 15 is the difference, right? Or what's different about it. What does that mean in terms of what this graph looks like compared to this? It's going to shift which direction and how far?
Up.
Right? 15?
I did hear, yes?
The plus 15 is where it's going to be on the y-axis.
That's true, but that isn't totally what I asked. I asked, how is it different from?
It's positive.
It is positive. I did hear the right answer. I just hear a lot of uncertainty, so I'm waiting for like a confident. Somebody said the right answer. I can't remember who it was. It goes upward. It shifts upward. How many units? 15. So this shifts upward 15 units. And because of that, if this is the mommy and daddy to make the little baby, it's going to have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It'll be a point like over there. Don't tell anybody I did that. You're freaking out. I didn't draw on the wall. Promise. I could probably just,
They can't see it.
good. Nothing happens beyond the frame of this video. Okay, if it shifts upward 15 minutes, and like Zach said, it is on the y-axis, what would we call or how would we identify the vertex of the function? It says type an ordered pair, so I'm going to have to give an ordered pair to describe that exact point of the vertex of this function.
I know.
Ricky,
Since there's no other number thing, it would be a 0 for the first one, and then it would be comma 15.
yep, so he's saying there's no number, so what he's saying is it's not shifting on the x-axis, so the x value of the coordinate will still be 0, just like this vertex, but since it's shifting upward 15 on the y-axis, that's going to be a positive 15 on the vertex. Let's see if I can make that thing disappear. Nope, that's there to stay, and now it's a big smudge. I never did that.
Just paint over.
We'll paint over it. It'll be a memory. Okay, so we have our vertex. Is there anybody that has a different function and you're not sure how to answer your question?
They're just all the same, so to put it in that order with your number.
Yeah, exactly. I just was asking the question what the question I was like actually asking in code was, did you not understand what I just did? So if anybody said, I don't know how to do mine, it would alert me to the fact that they have no idea what we just did. But you're right. What function did you get, Emily O?
F of x equals x squared plus 21.
How does your little boy look different on the graph than the mommy and daddy? I can't understand you.
It looks the same.
It looks exactly the same, so the little baby would be the same exact thing, same exact position?
No, 21.
What about 21?
It has a plus 21.
It has a plus 21. How does that affect the graph of the little baby?
It would go up 21.
It would go up 21. You want me to make another mark on this? 0, 1, 2, 3, 10, 11, 12, 15. Let's say that's about 21 there, okay? It's there!
It's not.
Right there. Okay, fine. Gosh, you guys are gonna get me fired. There you go. It's there. It looks like somebody wiped their blood or something okay. Blood, sweat, and tears goes into this class. Okay, so does that answer your question about what is it? What are your coordinates for your vertex?
0 and 21.
0, 21. Anybody else need help with theirs? Okay. Now we have a second part to this question. We know our vertex. Now it says, what's the axis of symmetry? We could probably answer that pretty easily.
It's 0, 15.
No, the axis of symmetry.
Yeah.
We need the,
Oh,
no,
it's 15, 15.
axis.
Oh, it's negative 15, positive 15.
So keep in mind that an axis of symmetry is an equation of a line.
Yeah.
So we would give an equation of a line, not an ordered pair. Yes. Nope. X equals 15 would be
Negative.
15 on the x-axis is over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then you'd be telling me that the axis of symmetry is all the way over here. But didn't we say that this function would be up here? X equals 0. The axis of symmetry is the y-axis, which we represent as x equals 0 because that's the value on the x-axis at this spot. Do you see how the mommy and daddy and the little boy have the same axis of symmetry? Because the only change is that this shifted upward. It didn't shift left or right. If it did shift left or right, would the axis of symmetry still stay the same, or would it be different? It would be different. Everybody good?
Wait, hold up. All the words.
What words are driving you?
Never mind. I'll ask Callie.
You can ask me. I'm right here. Are you afraid you're going to ask something that I've already said a couple of times?
Yeah.
Just try it. I'm not that scary.
I'm confused about did we do the axis of symmetry and the function is
Yeah, we just answered that.
Oh, it's 0?
It's not 0, it's x equals 0. The axis of symmetry is the y-axis, which we write as an equation of the line. The equation for the y-axis is x equals 0. Okay. Now, the wibbly is again different from the parent function. How is this wibbly different from the parent function? The difference, or the thing that makes this function different, is inside the parentheses. There's a number being subtracted from the input. Before, we had a number being added to the output. This is being subtracted from the input. It's changing the input before it's being squared. What is the rule? And you can look at your notes. What is the rule? Or tell me, how does this graph change when a number is being added or subtracted to the input? Basically, it's inside the parentheses with the input. How does the graph look different?
Negative.
Flippies! Parentheses 44?
The 44.
No. How does the graph look different? Okay, guys, remember when the little baby had the x squared and then we added 15, right? And we said, oh, when a number is being added to x squared, it just goes up that much. Cool. So it was a vertical shift. What happens when the number or something is changing to the input? It's changing inside the function. It's not just adding to the output and changing vertically. What is happening here? Anybody?
It's subtraction. Just signs are changing.
Let me kind of give you, what?
What did you do? How did you get x squared?
This is the last question that we did. I'm just reminding us that one question ago, we had a little baby that added 15 to the parent function, or to the output. And it caused an upward shift. We call it a vertical translation. But now we have a little baby that's not being added or subtracted to x squared. It's being added or subtracted to x and then being squared. How does that little baby look different on the coordinate plane? How is its position different from the parent function? It's shifting along the x-axis. It's shifting horizontally. Now here's the tricky question. Which direction does it go? Now remember, it can't go down because we're shifting this way. You're saying down. This is the one that has the vertical up or down shift, okay? It's going to the, she's saying it's going to the right. Do you guys agree or disagree?
No, it goes to the left.
Why?
Because the left side is negative.
Interesting. Do you guys agree with Abby or Emily?
Oh, no, okay. I remember you saying something about like the right side being negative.
Yeah,
But like the left side only has the negative. And it's
Yeah.
like confused.
it is, and that's why when I taught this, I said, this one's tricky, it's confusing. Because when it is inside these parentheses, when it's being done to the input, to the x, not the x squared, it actually moves in the opposite direction of the sign. So it's saying negative 44, but it shifts to, as Abby said, to the right. Okay? If this is shifting, if this mommy and daddy is shifting to the right 44 units, so let's say it's like somewhere over here, what is the vertex? If this vertex is shifting to the right 44 units, what is this coordinate point? I went from 0 to 44 on the x-axis. So you're saying the x value is 0 and the y value is 44? Switchies, right? So the x value is 44 and the y value is 0 because it does not shift upward or downward, it's just shifting to the right 44 units. To the right because it's negative. I know that sounds weird. So this is the vertex. Please let me know if you have a graph or a function and you still don't know what your vertex is. What does your function say? Okay.
G x equals parentheses x minus 52.
Okay. So yours is going from the parent function. Which direction?
Right.
Oh, you know what? I should be including all of this in here. That's not good. Okay. It's going to the right because it's negative. I know that sounds weird. It's going to the right. How many units? She has a negative 52. So it's going 52. Let's just say that's over here. What would your coordinates be for your vertex? So I'm not sure which one to address because there are two things that are not correct about what you just said. First of all, let's address the fact that you said 0, negative 52. Please tell me when I shift along the x-axis.
Oh, it'd be negative 52. Then 0.
Okay, so you did at least correct that the fact that this 52 is on the x-axis, but you're saying negative 52.
You said the right side is negative.
No, I didn't. We're not changing the value of the numbers on the coordinate plane. We're just saying that if it's a subtraction or a negative, it shifts to the right. The right side of the coordinate plane is still positive. Those are positive. The number line doesn't change. The x-axis is always going to be positive on this side and negative on this side. But when we read this function, the negative is actually telling us to move into the positives, to shift it. It's just like a thing. It's like you have to think about doing the opposite of what it says. So our x value is a positive because it's on the positive side. Even though it says minus 52 here, that minus says do the opposite of the sign. So we have a positive 52, 0 for yours. Do you get it? Okay. Now, how do we name that axis of symmetry? Let's do mine first and then we'll do yours, okay?
X equals 44.
Very good, x equals 44. How would we explain that in our work shown?
X is equal to 42.
No, because that is the answer. X is equal to 44, because of the function, that's the axis of symmetry.
Oh, the y.
How do we explain that in a sentence?
The y-axis?
We can say the axis of symmetry is x equals 44 because
The y, what is it called?
the vertex,
The axis of symmetry, that thingy is equal to the y-axis.
not quite.
What?
Can anybody explain to me how we know? I mean, we came up with the answer, x equals 44. We know that the axis of symmetry, how do we know that's where the axis of symmetry is?
It's on the. Wait, hold on.
Look at our definition of vertex. Look at the definition of a vertex. The vertex is the point on the axis of symmetry. So how can we use that definition to prove that the axis of symmetry is x equals 44?
44 is the point on the because it's directly on the line.
You guys, x equals 44 is the axis of symmetry because that's where the vertex is. The vertex is the point on the axis of symmetry. We have already proven in the previous part of the question what the vertex is. Now we can use that fact to say, well, if the vertex is at this point, then the axis of symmetry has to be the line that goes through it, right?
How was I explaining the like you know how like for the last one?
How would you explain the vertex part?
It says that why no I was going to explain like this, like the number, whatever number is on this side.
Yeah. Okay.
Because like
Yeah, you mean like this or like this, you mean?
yeah.
Yeah, so whatever the x value is,
Yeah, that's what I was trying to say.
totally. You could say that's what the axis of symmetry, the x value of the vertex is the axis of symmetry line. You can totally say it like that. Okay, do you need help on your axis of symmetry? Take a guess at what your axis of symmetry might be.
Well, I know that would be x equals 52.
Good, I'm just happy that you do know that. Okay.
Well, like, I don't know how I get that. Like, I don't know why.
Okay. Just like I said, we can prove that that your axis of symmetry is x is 52 because the vertex falls on the point 52, 0. And as Abby said, whatever the x value is of your vertex, that is your axis of symmetry. That's where your axis of symmetry has to go through on the x-axis. I know I just explained it in like 3 different ways. You can choose any of those ways
How would
to,
I write it?
in your own words. Do you still not understand it? Okay. It's hard. I'm not frustrated or like, oh, how do I? It's not you. These are so hard to grasp that like, even though I've taught it several times, I still have to pause and process when I do this. So I think I'm just like empathizing, like I feel bad because I understand how if you're learning this for the very first time, it just still is really hard to make sense of it in your head. So I'm gonna help you write your wording, okay? You would write something like, the axis of symmetry is x equals 52 because we can put it as simply as this. That's where the vertex is. That's where the vertex is, and the vertex is the point on the axis of symmetry. Does that make sense? Okay. Anybody else need help on theirs? All right, 2 more. Oh, goodness. Identify the vertex, axis of symmetry, and the direction of the graph of each function, which just means does it go upward or downward. So, this is going to be super easy, and I'll show you why. First of all, once we identify the vertex, doesn't that also tell us where the axis of symmetry is? Because the axis of symmetry is the line that the vertex, the line that goes through the vertex on the x-axis, okay? Does that make sense? So when we do these in order, it will help us. Let's identify the vertex first. This is given to us in what we call vertex form. A times x minus h squared plus k. Ricky, you gave me the definition earlier that the vertex is hk, and that's true. When we look at a function in vertex form, we can pull out the information for h and k and automatically get our vertex. That's how easy it is. We don't have to compare it with the parent function. We don't have to do anything. We're just saying, what is h? What is k? And then put them as a coordinate pair where you have h as your x value and and k as your y value. So how do we locate h and k in this function? How do we locate them? I'll give you a hint. Right above it, I wrote out the standard form. Yeah? I'm sorry, not standard form. The vertex form. Yes? Yeah. So can somebody tell me how I would locate h, the value for h and k in my function? Yeah, how would I locate it? I look exactly where the h should be and exactly where the k should be, and those are my values. Now pause for a quick second, because this is where you could get really confused about identifying the vertex. The signs are so important. H stands for get that sign the heck out of there. If I'm getting the positive sign the heck out of there, what is my h value? -5. So h is -5. Remember when we had a number here inside the parentheses with the input and it shifted in the opposite direction of the sign? Remember that? That's why we say h stands for get that sign the heck out of here. H for heck. I don't know why. So when we take the 5, or this +5, we say the actual value of h, or the x position of my vertex, is actually going to be the opposite sign from what I see. If it says positive, it is negative, because it's really shifting to the left. The +5 means shift to the left. Remember we just did that? So we would identify that h as -5, because it would be to the left. Does that make sense? kind of. Now the K, I say that K stands for keep that sign.
Keep changing what?
Sure. Keep that sign, which makes the K coordinate part really easy. So if it says +1, it's +1. So when we put it as a coordinate pair, we have -5, +1. So it gave us a +5, but we get that sign the heck out of there and make it negative. We get a +1 and we keep that sign, +1. This is the vertex. Raise your hand if you need help identifying the vertex of your graph. Everybody's good? Okay. Now let's do the axis of symmetry. And it's really important that I'm going to keep the coordinates of my vertex right here. I'm not going to erase it because this is going to help me find my axis of symmetry. The axis of symmetry for a parabola is always going to be along the what axis?
Wow. What was the question?
The axis of symmetry for a quadratic function, a parabola, is always going to be along the x-axis. When it's right here, it's x equals 0. If it's right here, it's x equals 2. If it's right here, it's x equals 10. If it's right here, it's x equals -9. It's going to be along the x-axis. Therefore, what are we going to use from our vertex? Yes. Do you like geometry entries? Great. Is that terrible? Is that okay? Good catch. We use our x value of the vertex to determine the axis of symmetry. Yep, for this function, because it is the x value of my vertex, and if you wanted to explain that, you would say the axis of symmetry is x equals -5 because it is the x value of my vertex.
What was mine? Because I put mine in and you said it was wrong.
You put your vertex in and said it was wrong? Okay, give me your function.
F of x equals 7. X plus 1. Squared plus 4.
Okay, what did you put as your vertex?
-1 and 4.
Good, that is correct. Did you put it in parentheses with a comma?
But it said the axis of symmetry.
Okay, so this is vertex. Did you put this in for your vertex?
Yeah, I put it.
Good, and is that it was correct?
Yes.
Okay, I thought you were telling me that it told you your vertex was wrong.
No, I was telling the axis.
What did you put for your axis of symmetry?
-1.
You have to put x equals -1. Because if you look in the little down here, for the axis of symmetry, it will say type an equation, not just, because this equation represents an entire line on the graph. If you just put -1, it has no idea what you're talking about. Because it's a dumb computer. Computers can't think and reason. Okay, we still need to, now it says, okay, there are 4 things we need to do for this. It says, let's talk about the direction. The question after this is exactly the same question, so you'll just need to practice with that. The direction of the graph of the function, okay? What direction? Is it gonna be a happy parabola or a sad parabola? What makes it sad? What's negative? So the do you guys agree with this? Emily is saying that we determine whether it's Emily A. I really suggest you listen to this. What are you working on?
I'm working on that.
I know, I just feel like if you're not paying attention to this, you're not gonna like learn enough to work on it on your own. Okay.
I'm working on it on my own. I just got it right.
Okay. All right. Explain this to me then, Emily A. What part of the function determines whether it's a happy parabola or a sad parabola? No, this is,
question again?
okay, yeah. What part of this or this, you can name either one. What part of the quadratic function in vertex form, what part of it determines whether it's happy or sad? Upward, downward. There's one specific part of it that makes that determination, whether it's happy or sad. Yeah. Wait, what? No, not the. Did you say H? Did you say H?
No, she said A.
Okay, sorry. I thought you were saying A, and I was saying very good, but then you said shh, and I said no. Okay, that's why I'm not trying to like drive you nuts, but like that's why when I see you working on your own, I'm like, oh, that's awesome, but like I'm going over things that I feel like you're gonna need. And so what I'm talking about now is the direction of the graph. It seems like we all need help with this. What is it?
It's a positive because the leading coefficient is positive.
Very good, and that's your explanation right
The
there.
leading coefficient is the very start. That's how you
Yep, the leading coefficient, which is A, which is our 5, is positive, so it opens into a smiley face, a happy parabola. It opens upward. So this is what determines if it's positive, it opens upward. If it's negative, it opens downward. It's called the leading coefficient. You can just call it A if you want. This A is the leading coefficient, but if you want to just call it A, that's totally fine. The last part says compare the width of the graph. What part determines the width of the graph? Width meaning, is that opening going to be wide or narrow? Yeah.
Is it if it's greater than 1?
If what is greater than 1?
X is greater than 1?
Not X.
leading coefficient.
It's the leading coefficient again. So it's A again. A will determine your direction and your width. I can tell you're zoning. A, this number right here, determines your direction by its sign and your width by its absolute value. 5 is greater than 1. When it's greater than 1, does that cause the function to narrow or widen?
Narrow.
Narrow.
Because if it's above 1, it's going to end.
Yep. So it says compare the width. The width of this function will be more narrow or narrower than the parent function. If it's a decimal number, so like 0.5 or 0.03 or whatever it is, that will get wider. Does that make sense? There's one more question on there. You should be able to answer it based on everything we just